Today I'm gonna talk about derivative of composite function, chain rule, trig function, part 2. Okay, so let's recall the chain rule. The derivative of capital F, little fx equals the derivative of capital F, fx times the derivative of little fx. Okay, so here the capital F can represent any trig function. For example, if capital F is secant, then the derivative of capital F gonna be secant times tangent. If the capital F is cosecant, then the derivative of capital F gonna be negative cosecant times cotangent. If the capital F is cotangent, then the derivative of capital F is negative cosecant square. Okay, and I think in the chain rule, the most important function is this little fx. You need to identify what is little fx. Okay, what is a little fx? After you identify this little fx, you just need to plug in. And I also list all the other formulas that can be used to solve the following examples. The second one is power rule. The derivative of x to the power n gonna be n times x to the power n minus 1. The third one is constant multiple property. Okay, or constant multiple rule. The derivative of a constant times a function fx gonna be the constant times the derivative of this function. Okay, we'll keep the constant the same. And this one is the derivative of secant x equals secant x times tangent x. The derivative of cosecant x equals negative cosecant x times cotangent x. The derivative of cotangent x equals negative cosecant x squared. Now let's take a look at the following examples. Now, the first example is secant kx derivative. Okay, derivative. So let's take a look. What is capital F? Capital F is secant. Okay, secant. What is little fx? Little fx, we can easily tell, is this guy. So little fx equals kx. Okay, this guy. Now we can follow this formula. We can plug in. So derivative of secant, or derivative of capital F, gonna be secant and tangent. So we have secant fx kx and times tangent tangent kx, and plug in the fx for this derivative. Okay, so we have kx prime. Okay, and now for the last term, we can see that is the constant multiple rule. Okay, we're gonna keep the constant the same and only do the derivative for the x. Okay, so keep the constants the same and do the derivative for the x. And we know using the power rule, derivative of x gonna be, because the exponent is 1, right? So n equals 1. So x to the power 1 minus 1 should be x to the power 0. X to the power 0 should be 1. Okay, so derivative of x should be 1. Now we can simplify it. We have k secant kx times tangent kx. Okay, now let's take a look the second example. For the second example, what is capital F? Capital F is cosecant. Okay, cosecant. And what is the little fx? Little fx is this guy. Fx equals x squared plus 3 times x to the power 4. Okay, now we can follow the formula. Derivative of this capital F and corresponding to derivative of this cosecant. Okay, derivative of a cosecant, we're gonna follow this formula is negative cosecant times cotangent. So it should be a negative cosecant fx. So we have x squared plus 3x to the power 4 times cotangent x squared plus 3x to the power 4 and times derivative of fx. Fx is this guy. We have x squared plus 3x to the power 4 prime. Okay, so basically we're gonna simplify this guy. How to simplify this guy? That's the derivative of sum of two functions. We're gonna do the derivative for each term. So we can copy it. The first two terms. Okay. And for the last term, we can do the derivative. For each term. Okay, and now the derivative of 2x gonna be a power rule. We can write down as 2x 2 minus 1, right? And the derivative of 3x to the power 4 gonna be a constant multiple rule. So we can do the 3x to the power 4, right? X to the power 4. And the derivative of this guy, we're gonna use the power rule again. So we can write down all the terms like that. Negative cosecant x squared plus 3x to the power 4 cotangent x squared plus 3x to the power 4, and for the first term we can write down as 2x to the power 2 minus 1. For the second term we can write down as power rule 4 times x to the power 4 minus 1. Okay, and now we can simplify it. Cosecant, we copy the first two terms and we can simplify the last term. So for the last term we have 2x and plus 3 times 4 is 12 x to the power 3. Okay, now let's address the last example. For the last example, cotangent ax plus bx to the power 4. Here a and b are constant. Okay, so the first thing we're going to check, what is capital F? Capital F is cotangent. What is little fx? Little fx should be ax plus bx to the power 4. So we can write down the little fx on the top. Ax plus bx to the power 4. Now, let's follow the formula. Derivative of capital F. Here's derivative of cotangent should be negative cosecant. Okay, so it should be a negative cosecant. And fx, we're going to copy fx is ax plus bx to the power 4 and times derivative of fx. Derivative of fx plug in, we're going to do ax plus bx to the power 4 prime. Okay, and we try to simplify the last term. And as we can say, for the last term, we do the derivative of the sum of two functions. That means we're going to do the derivative for each term. Okay, do the derivative for each term. And again, we can tell for the first term, ax, that means we cannot apply the constant multiple rule, right? So we have a times derivative of x. For the second term, again, very, very similar. That should be a bx to the power 4 prime. Okay. Now, we can simplify it again. Negative cosecant ax plus bx to the power 4, and for the first term gonna be a times derivative of x, should be a 1, and for the second term gonna be a power rule, right? Is 4x to the power x to the power 4 minus 1. Okay, and we can simplify it. We have negative cosecant ax plus bx to the power 4 is a plus 4b x to the power 3.